All right, guys, welcome to this page of the notes, and what we're going to do now is talk about our third type of variation function, and it is known as the inverse variation. We're going to talk about why it's the inverse variation to kind of help you guys recognize it, but as always in the problem, I will tell you what type of variation it is. You'll just then need to be able to write the equation. So, y varies inversely. We're familiar with the term inversely. We'll show you how it works here in just a second. Inversely as x if there is some non-zero, so there it is, my constant k, my constant of variation k, which for this particular type of variation will never change. And so here I've got the inverse variation equation for you. Y is equal to k divided by x, right? This is different than the direct variation. The direct variation was y equals k times x. This one is y equals k divided by x. Let's talk about why that is. All right, so here we go. I've got y equals, that's my highlighter, hold up. I've got y equals k divided by x. K is the constant, so we'll go ahead and solve for k. In order to solve for k, I'll have to multiply the x to the other side. And what I wind up with is k is equal to y times x. All right, now let's talk about this for a second. Let's say that k is equal to 30. Right? Let's say that k is equal to 30. So this is my constant variation. It's the number that never changes. It'll always be the same for a given problem. So let's just say that for this particular example, k is equal to 30. Well, let's go ahead and talk about why this is known as inverse variation. Here's what I know. I know that k needs to be equal to 30. So my first example problem, I have 30 is equal to, let's go ahead and pick, right, an easy one, right? An easy one would be 5 times 6. So here's what I've got. I have 30 is equal to 5 times 6, right? So the value of y is 5. The value of x is 6. Okay? Now, that one by itself doesn't really show me anything, but I'll begin to see something as I try another one. We know that it still has to be equal to 30, but another way to get 30 is if you did 10 times 3. Now something interesting begins to show up. Please notice, k is 30, it never changes, constant variation. But here's what happened. Y was 5, right? Y was 5, that was the value of y. It has increased to 10. The y value has gone up. But the x value, which was 6, has now dropped. It's gone down to 3. So one value went up, the y value went up, the x value went down. Inverse relationship. As one variable goes up, the other one has to go down. If that y variable comes down, the x variable will have to go up. Let me show you. One more, I think I can squeeze it in here. 30 is equal to 15 times 2. Sorry, I apologize, I'm squeezing big time over here. But please notice the y value has increased again. I went from 5 to 10 to 15, right? That y variable just keeps going up. It's increasing. But because it's an inverse relationship, I know the x value has got to go down so that I maintain that constant of variation. And that's exactly what we see. X was 6, then it dropped to 3, now it is dropped to 2, right? That x value is going down as the y value is going up. That's the inverse variation part. So we've got this inverse variation formula, but again, the one we're going to use more often than not right here. I won't even write that whole 2-point thing anymore because you don't really need it. First set of conditions, x1, y1. Second set of conditions, x2, y2. Again, the values of x and y don't matter. They always will have to come out to be equal to my constant of variation, k. Since that value of k has to be the same regardless of the value of x and y, we can go ahead and set these guys equal to each other. And here we go. I have a very useful formula. You can use either one of these. I don't really care which one you use. Probably whichever one is easier for you to remember. x1, y1 equals x2, y2. Or what I've done is I've divided, right, divide the y2 to this side, so x1 over y2 equals, there's my x2, divide the y1 to this side over y1. Now I have an x and a y value on both sides, but again, it really doesn't matter which one of these you use. And in fact, I probably will use this top one most of the time. But if one of them happens to work better for you, have at it, all right? Whatever floats your boat, all right? Let's do an example problem. So here we go. I'm going to start by writing my variation equation, and I'm told that R varies inversely as T. Well, I need to write my inverse variation formula, so I'm told that R varies inversely. So R is equal to some constant K divided by T. I know it has to be divided by T because they tell me it's an inverse variation. Solve for K. That means I have to multiply the T to the other side, and I wind up with K. That constant variation is equal to R times T. Now again, I can consider an initial and a final set of conditions and get R1 times T1 is equal to R2 times T2. And it's too bad that I didn't pick D's because then I'd have RD2, R2D2. But anyway, forgive me for my Star Wars reference. Here we go. Let's go ahead and plug in what we know. 18 and -3. I'm asked to find R when T is a -11. All right, so awesome. Here we go. I'm going to have 18. That's my R1. -3. That's my T1. Is all equal. I'm asked to find the other value of R, which in this case will be my R2, when T has changed to a -11. So there we go. I need to solve for R2. Really easy. This is multiplication. Please divide that -11 to the other side. I get R2 is equal to 18 times a -3 divided by a -11. Guys, easy algebra problems. Also, it's plug and chug on a calculator. Plug it in. Don't fat finger something on your calculator. Please reduce your fractions. I get 54 11ths. Yeah, 54 11ths. It won't be negative, right? Because the negative and the negative cancel each other out and leave you with a positive fraction. 54 11ths is what I get when I do that. All right, so plug and chug on a calculator. Just don't fat finger something. You should be good. Okay, let's try another one. Right, the formula, I am told that X varies inversely as Y. No problemo. X varies inversely, so K over Y, right? I know I have to divide by Y because I'm told it varies inversely as Y, so that Y's got to be in the bottom. But I'm going to solve for K. X times Y. Again, if I had two sets of conditions, that would be X1, Y1 is equal to X2, Y2. And it's time to plug and chug. I'm told X is 24 when Y is 4. That's all got to be equal to, I'm asked to find X, so X2 when Y is 12. Once again, divide that 12 to the other side. Very easy algebra problem to solve. 24 times 4 divided by 12. Plug and chug on a calculator, don't fat finger something, and I get that value of X has to be an 8. That value, right there, that value of X has to be an 8. All right, guys, that takes care of direct variation, where you have Y equals K times X. Joint variation, where you have Y equals K times X times Z, or whatever the variables are, but it's jointly because there's two of them. And then this inverse, where you have Y equals, or X equals, whatever, Y equals K over X, right, where we see that division because it's an inverse variation. Head on over to the next page of the notes. We'll take a look at our last type of variation function. I'll meet you guys there.